The second question here says, a hollow cylinder has a charge q coulomb within it. If phi is the electric flux in units of voltmeter associated with the curved surface B, the flux linked with the plane surface A in units of voltmeter will be. So we need to find the electric flux that is passing through this plane surface A. And we know that the electric flux passing through the curved surface B is simply phi. So I can say that phi B is equal to phi. Now, if phi E is the entire electric flux that is passing through this closed cylindrical surface, I can say that phi E is equal to phi A plus phi B plus phi C. Because we know that the closed cylindrical surface here is made up of three open surfaces, two plane surfaces A and C and the curved surface B. So we can say that the net flux passing through this closed cylindrical surface will be the sum of individual electric flux passing through each open surface here, that is making up this entire closed cylindrical surface. Now, out of symmetry, phi A will be equal to phi C, because these two plane surfaces A and C are equidistant from the charge q and they are equal surfaces, they are surfaces of equal area. So based on that, we can say that the flux passing through the plane surface A will be equal to the electric flux passing through the plane surface C. So phi A is equal to phi C. If that is true, this equation here would become phi E is equal to 2 phi A plus phi B. And that is because I can replace phi C with phi A, and then it would become phi E is equal to phi A plus phi B plus phi A, that is 2 phi A plus phi B. Now, we know that the electric flux phi E passing through this closed cylindrical surface here will be equal to Q enclosed by epsilon naught. And that is according to Gauss theorem. And if that is true, in this case, Q enclosed is simply Q. So we have phi E is equal to Q by epsilon naught. We know that phi E is 2 phi A plus phi B. So we can say that 2 phi A plus phi B will be equal to Q by epsilon naught. Now, phi B, you know, is simply phi. So I can say that 2 phi A plus phi is equal to Q by epsilon naught. Phi B is the flux that is passing through the curved surface here, and that is given in the question is simply phi. That is how we can replace phi B with phi. Now, 2 phi A would then become Q by epsilon naught minus phi on rearranging it. And if that is true, I can say that phi A, which we need to find out, the electric flux passing through the plane surface A, phi A will be equal to 1 by 2 multiplied with Q by epsilon naught minus phi. Now this is our solution. Let's look at the options. Option B matches with our solution. Phi A is equal to half Q by epsilon naught minus phi. So that is how we solve it.